Hello, my name is Zain Mohammed and this presentation is for my Applied AI coursework. My project focuses on the application of artificial intelligence in the education domain, and this is the domain I have chosen, specifically using machine learning techniques to predict student academic performances, such as grades and etc. The main goal of this project is to identify students who may be at risk of failing by analyzing academic, behavioral, and demographic data. By identifying these students early, educational institutions can intervene sooner and provide targeted support to improve student outcomes and retention. And this has been implemented through the use of the Jupyter notebook, as you can see here, along with the code. And I will be going through this today. I chose education as my application area because it generates a lot of data, especially from online learning platforms and learning management systems. Things like attendance, grades, engagement with materials, and submission patterns can all be analyzed using AI softwares. One of the most common uses of AI in education is student performance prediction. Machine learning models are trained on historical data to predict outcomes like final grades or whether a student is at risk of failing. These predictions are useful because they allow educators, such as teachers, to intervene earlier and make sure this doesn't happen. Another application is intelligent tutoring systems, which adapt learning content depending on how a student is performing. Learning analytics is also important as it looks at patterns in student behavior, such as how often students log in or how they study, to help improve teaching strategies. Even though AI can be very useful, there are also challenges, especially around data quality, privacy, and bias. Because of this, AI systems in education should be used as decision support tools rather than replacing human judgment, which is the most effective technique. We'll be moving on to part B now. For part B, I compared 3 AI techniques that can be used for predicting student performance: logistic regression, decision trees, and artificial neural networks. The overall goal across all 3 techniques is the same: to predict whether a student is likely to pass or fail based on their data. Logistic regression is a simple supervised learning method used for binary classification, like pass or fail in education. In education, it can use features such as attendance, study time, and previous grades to estimate the probability that a student will pass. One of its main advantages is that it's very easy to interpret. You can clearly see which factors have the biggest impact on the prediction. However, it assumes a linear relationship between inputs and outputs, which means it might struggle with more complex patterns in the data. Moving on to my next technique, decision trees. Decision trees work by splitting the data into a series of rules. For example, a tree might first check attendance, then previous grades, and then study time to decide whether a student is at risk. They're easy to understand and visualize, which is great for education. However, they can overfit the data if they're not controlled properly, meaning they might perform well on training data but poorly on new data. And the next technique, neural networks. Neural networks are more advanced models that capture complex, nonlinear relationships between features. This makes them very powerful for educational data where multiple factors interact in complicated ways. The downside is that they are harder to interpret, and usually they need more tuning and computational resources. Despite this, I choose a neural network for my implementation because it offers better predictive performance for more complex datasets. I'll be moving on to part C now. Mm, Sorry, I was just having an issue with part C because my diagram wasn't showing properly, but now it is. Uh, yeah, I think it's fine now. Okay, this is the diagram I've created, and I know it's simple, but gets the job done. The diagram shows the overall structure of the system. The process starts with the student uh, performance data set, which is then cleaned and pre-processed. The features are scaled so that no single variable dominates the model. The data is then passed into a neural network, which produces predictions that are evaluated and visualized. Input data and pre-processing. To make sure my notebook could run without any issues, I generated a synthetic student dataset directly inside the Jupyter notebook. This avoids relying on external files and ensures full reproducibility, which is easier for the marker to use and open. The dataset includes features like age, study time, absences, previous grades, family support, internet access, and the target variable. The target variable is binary, where 1 represents a student who passes and 0 represents a student at risk of failing. Before training the model, I scaled the features using standardization and split the data into training and testing sets. This helps the neural network learn more effectively and allows me to properly evaluate its performance. Here you can see the code and the actual implementation in the notebook. I use a multi-layer perceptron neural network with 2 hidden layers. The model is trained on the training data and then tested on unseen data. The output includes an accuracy score, a confusion matrix which shows how many students were correctly and incorrectly classified. And you can see this when I run this. If you restart it, it's just going to take a minute. It's just loading. Yeah, and this is the outcome when the code is run. As you can see, the table, this, and the confusion matrix. Moving on to part D. To test the model, I used an 80-20 train test split, which is a standard approach in machine learning. This allows me to check how well the model performs on data it hasn't seen before. Accuracy was used as the main evaluation metric, and the confusion matrix helped me understand the types of errors the module made. The results were mostly in line with expectations. Students with stronger academic indicators were predicted to pass, while students with weaker indicators indicators were flagged as a risk. In an educational context, this kind of model could act as an early warning system. However, it's important to be careful because missing an at-risk student is usually more serious than incorrectly flagging a student who's actually doing fine. Moving on to Part E, ethics, inclusion, and sustainability. Using AI in Using AI in education raises important ethical issues. If a model is trained on biased data, it can unfairly disadvantage certain groups of students. Because of this, predictions should never be used on their own. They should support educators rather than replace them. And students should always have the opportunity to receive help rather than being labeled. There are also environmental considerations. Training neural networks use computational resources, which means energy consumption. While my model is small, large-scale systems should focus on efficient models, limited retraining, and responsible data storage. To conclude, this project shows how AI and neural networks in particular can be used to predict student academic performance. This system is fully reproducible, works entirely within a Jupyter notebook, and produces meaningful results that can support early intervention in education. While the model performs well, it's important that AI tools like this are used responsibly and alongside human judgment. Here are the references as well. Thank you for listening. Goodbye.